Well, with that, I think we'll kick off, and we're going to try to cover what we've heard as interesting topics. But ask questions, chat with us, direct us as you'd like. This really is your time. But some of the subjects we're going to cover, of course, are what's new in 0.9 and what's coming in 1.0. But also, what does this contribution of OpenEBS itself into the CNCF, what does that mean? And how is that going to change things for all of us? And we're going to do a demo or two as well. And to be open, we have some requests of things that we'd like help on as well.
Thank you so much, Ivan. Patrick and I will try to go over new features of 0.9 and some highlights from Kubecon, and then we'll talk about what's coming and also take questions after. So quick reminder of CAS architecture and benefits. Well, we still have all the options, but before container attach, we had centralized NAS and SAN and EBS like option commonly used. And then problem with this approach is that NAS and SAN still require an initial investment and configuration, and you have still a gatekeeper who developers, DevOps persona should talk to get a new shared space, a LAN or more space, and features are tightly attached to one vendor or one location. Even in one data center, you have mix of storage vendors, and different snapshots are not transferable across vendors or locations, and then pretty much they are not agile up to speed how you consume, similar to the ways how you consume Kubernetes. And also separately, EBS and cloud storage has its own issues that everyone is aware of. And the other option available is direct attached storage and host path or local PV. With this approach, you get some level of agility, but you don't get the storage high availability or snapshots and clone in Kubernetes. And CAS is solution that is completely cloud native and designed the way Kubernetes and applications are designed, microservices based storage solution, just like your application on Kubernetes. And it can coexist with other solutions, and actually abstracts the storage layer, can sit front of your storage backend or manage just bunch of disks for simplicity. And OpenEBS is a leading container attached solution in the market today, and native to Kubernetes, app granular, and then really the idea from the beginning was simplicity, ease of use, gives teams autonomy, 100% open source in user space, free from kernel modules and dependencies, additive to underlying systems or cloud volumes or JBots.
And to that point, Murat, on the prior slide, right, we kind of set up the dichotomy. But I think part of what we're going to talk about right now is the fact that OpenEBS can also help you use those local PVs. So you really see, and in fact, OpenEBS runs on top of your if you wanted to, your existing SAN as well. So we're not trying to say that if you have a existing SAN, and you want to use that, that means you wouldn't want to use CAS. No, CAS can run on top. If you have local PV, no, CAS can run on top. And in fact, CAS, at least our CAS, can help you manage that as well. But it is a new pattern that seems to be taking off, as we'll talk about a little bit more later on.
Yeah, thanks, Evan. And we'll talk a little bit about, again, MayaData's enterprise offering. Our mission at MayaData is to provide data agility for DevOps use cases. MayaData's commercial offering bundles OpenEBS Enterprise, Litmus Chaos Engineering Tool, and Maya Online for visibility and control plane under one dashboard to simplify management, and we provide proactive support through Maya Online. With Maya Online, you get better top-down visibility from your applications down to disk level. There is a nice topology view you might be familiar with already, and manage the impact, maintenance, performance, pretty much all second-day data operations, where with Litmus you can inject chaos and run your E2E tests on applications, and then to provide some trust points, and then again on Maya Online you get a DMAS, data migration as a service functionality, which is simplified view, scheduled backups for disaster recovery. So if you missed us at Kubecon Europe in Barcelona a couple of weeks ago, so we were there as a team and met with many of our users in Europe and also from US. And in addition to that, this time OpenEBS was on the keynote device. Brian Lills, senior staff engineer from VMware, introduced introduced OpenEBS as a new sandbox project. This was a really exciting moment and a great milestone for the community. Congratulations to everyone. What does this mean for our community? Of course, more visibility. Also, it means we as MayaData gave away rights to our site OpenEBS, and then all the vendor specific content will move into MayaData.io. But also this also means OpenEBS is no longer and then from the beginning this was the intent, not a single vendor product. It's a 100% committed to open source multi-vendor solution. Now it's part of CNCF. Anything you want to add here, Evan?
Yeah. At first, I was going to put, possible impact to you, none. I mean, the good news is we, as a company, are of course getting bigger, and we remain 100 or 1,000%, let's say, committed to OpenEBS. But there's a standard, open, independently governed process for the, let's say, 390 contributors so far that don't work at MayaData to make sure that their contributions are fairly treated. And we like to think we've been that way all along, but this really validates that and makes it more the case that it must be that way. And so as such, there are independent OpenEBS community meetings happening on a weekly basis in which contributions are assessed, discussed, roadmap, and so on. That heartbeat existed previously. We've gotten some more input, coaching, and direction from the CNCF itself. They're also giving us things like a mailing list, okay? And Slack will still be there, don't worry, we're still there. But in addition to that, there's a mailing list being launched for the community as well. And there may be a couple of flavors there. One is very, very focused on, you're contributing to OpenEBS. I do think it's really important. I mean, storage traditionally has not been an open domain. And we really are partnering with, I know, Murat, I think you're at a storage vendor today or tomorrow here in the Valley, who's taking a piece of the OpenEBS project, at least that's our understanding, and using it themselves for some other use case. And that's great. We want to embrace that and support that. So we think being in CNCF is as much about giving confidence to the other possible contributors as it is anything else. And you're just seeing more users, more contributions, thanks to being in there.
Thanks, Evan. So now let's take a look at 0.9 features here in a moment. So this is recently released and at around KubeCon. So we are really excited about this, and even before the release, this was an interesting moment. At KubeCon, we had users stopping by and already picking up the bits and using this local PV functionality successfully. So what this provides is there are still applications that you may wanna use the replication from the application and then just use the local PV instead of OpenEBS provide high availability. So then you can grab a piece from a local PV, and there are two modes in a moment Patrick will talk about. But also automate and orchestrate all the required steps because manually configuring and a second-day operation might be a bit painful. And then we recently also introduced Heptio Velero plugin. So now you can take C-Store volume backup to S3, meaning AWS S3 or also Minio S3 backend. So what is different with OpenEBS compared to other Heptio Velera solutions? As you may be aware of, C-Store is copy on write, and then so when you take a snapshot with C-Store based engine per system volumes, your backup initial is a full size backup, and the additional after that point backups are differential, meaning that every time you get the snapshots after and then backup after, they take less space, and that means putting the backup into S3 backend is going to be faster and also will take less space. They are very efficient. And also we added some performance tunings for C-Store. This was a highly requested functionality. So now you can optimize your C-Store targets based on applications needs. And there are a bunch of also stability and hardening fixes. Also we are preparing for 1.0 in the meantime, and a lot of functionality went into 0.9 already. So you can set a replica affinity for better HA. Also C-Store volume affinity to assure co-location of target paths and target paths and application paths, and also faster Jiva volume replica rebuilds. We made some improvement in the Jiva engine as well. You can find more on the blog. And with that, we are preparing. This is again another exciting milestone. We are getting ready to towards 1.0. So what that means is, so functionality-wise, there is not much. There are not too many large functionality going into 1.0, but we are hardening the product and then putting more testing in the background, make sure that APIs will be there and then solid. And future-wise, local PV with block devices and block device claims will be there. And also C-Store pool with block devices and block device claims again needed this so that OpenEBS, when used with C-Store on local PVs, will not step on each other. And also some I should call it migration tools, but upgrade functionality, automated upgrade functionality to help with existing C store pool changes is getting into 1.0. Your feedback is really appreciated. This week, RC1 is released, and you can take the bits from the OpenEBS repository and give us your feedback. And of course, there is more. This is again announced around Kubecon. MayaData team announced a new open source project. It's called KubeMove. This is the intention is to create an open source solution to and also work together with the community to define custom resources and APIs to extend Kubernetes to data mobility and across all cloud vendors and all platforms.
Just a quick comment on that, guys. We could flip back for a second. This is an opportunity for us collectively and for the broader community to try to extend Kubernetes itself and the openness that it's brought to all of us to some higher level capabilities. And it's, having seen the movie just a few times over the years of open source ecosystems beginning to diverge, I don't think we're quite at that point. I think it's incredible the amount of forethought that is in CNCF, that has gone into CNCF, including making sure that really all of the Kubernetes out there does work in the same way. So OpenEBS, for example, can run anywhere. But if you want to move your data into and out of these clouds, as an example, you ought to also have that same confidence, trust, and commonality of experience. That's our vision. We wouldn't have thrown this out there if we didn't have some, at least CTOs at some large clouds saying it's a good idea. But it's at that nascent state, and it's got to be driven, led by those who really believe in the mission of Kubernetes and bringing that to the data itself. So we're excited about it. We're hopeful that these CTOs and others, including large enterprises, will kind of get behind this. And in fact, right now, you want to contribute to open source, give it a yes, give it a star on GitHub. I mean, it all helps. Let's get a little more visibility to this. So sorry for my soapboxing there, Murat, but thanks.
Yes, really important. Yes.
Some of the users.
And moving forward, this is really an important piece for Kubernetes in itself. And so, of course, with the announcement, OpenEBS getting into CNCF, and also this is the second time with KubeCon we are in Europe, so we met with many users, and we realized actually OpenEBS has thousands of more users than we have in the Slack community. This was an exciting moment for the team. So we found out about new large industries or users using OpenEBS. You can imagine the names, but large automotive industry users and financial service and similar ecosystem. A lot of European public sector organizations and cloud managed service providers, also software vendors. This is also very important for the community, building their platform on and solutions using OpenEBS, and now they are also showing up in our Slack channel, and really this is a nice moment for the community. They are helping other community members or other software vendors to build their solutions. There is definitely a strong demand for data science platforms, CI/CD platforms, and multi-cloud storage solution, and OpenEBS is used underneath. And this is also an interesting use case, growing OpenEBS at the edge. edge computing is a method of optimizing cloud computing systems by performing data processing at the edge near the source of data. Most of the telcos in that category, but also processing at the source of the data is often called far edge. This is a big opportunity OpenEBS is enabling. Far edge may mean IoT devices or set-top boxes or autonomous self-driving cars where data is collected at the source, but at the same time that means that resources may not be as large as data center. Very low footprint solution is required. And ETC is a standard IoT gateway. This is an example why OpenEBS works in this use case. So MayaData Agility Platform, one common data plane and control plane, really, especially with Jiva low footprint, can run on ARM devices just using the SD cards, and also run without requiring additional nodes to compare to scale out storage solution systems. Many of these locations, far edge locations, only have a limited number of nodes, x86 or ARM with local disks. And OpenEBS enables all these use cases to actually use Kubernetes. And this is the last piece from the announcements. Another exciting moment. They are all equally exciting, but new storage engine. We have demoed a new storage engine in development. This is close to alpha. And we have demoed multi-million IOPS provided by this new storage engine. Extremely fast, also targeting on-prem NVMe persistent memory, storage class memory use cases where you have low latency, high IOPS devices. This removes some of the protocol overhead, and currently we use and we call this cloud native data fabric. It is to be released later in this year. Some alpha users playing with it now. More if you are interested.
I actually have a question just saying performances have improved over the versions, have really improved. So thanks for that. Will they continue to improve over time? This might be a timely moment to answer that, and also you could mention local PV maybe.
Yes, local PV, if your application have high availability built in itself, local PV, you get pretty much zero overhead local storage performance, but without the snapshot, clone, all the enterprise functionality. And then this new storage engine really focused on on-prem new environments, fresh, all new technology using some of the latest Intel SPDKs and NVMe over TCP protocol, but we name to be determined. We call it now Cloud Native Data Fabric.
And there's probably a third axis, which is just so as you said, local PV, that's there now. It's in, I think we're saying it's in beta now. It was in alpha. Am I right about that? Murat?
Yes.
And so for these IO intensive use cases where you have a reasonably fast disk underneath, it's going to be as fast as the disk, which is generally a lot faster these days than your monolithic scale out storage systems, as an example. So that's good. As you said, I won't repeat it, the NVMe that's coming. But the third axis would be, we've added some tuning to CStore itself, basically productize some of that tuning. And we don't think CStore will ever be a high performance engine, but part of the power, right, of container attached storage is it's more or less per workload.
Yeah.
And so what this means is you're tuning, if you tune it to optimize for a write-ahead log, as an example, over here, and over here the data is a different type, well, you can have two separate tunings that, one of which for the write-ahead log in a database would slow you down over here. That's fine. It's you have two separate instantiations of OpenEBS with separate tunings. That'll work. That level of customization and control and granularity has always been there in the architecture. Now with 0.9, we made it a bit easier, and we're happy to help you, on the Slack community or otherwise.
Yeah, to be clear, when we say yes, C-store, we have users also getting 70, 80,000 IOPS from C-store. When we say really high performance, this is extreme high performance, millions of IOPS that are available through new.
Just say one more thing. We're all storage engineers underneath. And the traditional way of testing storage is to, hey, let's do IO meter. Let's pound this shared resource. Let's see how fast we can make our shared SAN run. And that's fine. That's good. And then they turn to one instance of OpenEBS C-store, and they say, I can only get it to 60,000 or 70,000 IOPS. That's slower. Okay, wait a minute. C-store tends to be deployed very much on a per workload basis, right? Now, you actually do have a pool construct in C-store, but you've got to look at the aggregate number of C-store instances running against all of these workloads up above. So 60,000 IOPS for a particular database may be plenty, and then keep in mind on the cluster next door, you also have 60,000 IOPS, and on the one down there, the other pod, you have 60,000 IOPS. And so the point is that this CAS, container attached storage, introduces a new paradigm, and you got to do some addition to come up with what that aggregate capability is. It's not as simple as pound one OpenEBS instance and say, oh, it's slow. No, you got to look at, if you're going to do apples to apples, compare it to legacy SAN, you got to look at many workloads and do that comparison. So anyway, it's a great question. Performance is important. We have come a long way. You can tune the existing systems better. You can use local PV. And we've also invested millions in what will be coming out later this year, which we think will be one of the fastest systems available, this NVMe-based system. We promise the next question we will answer in a more succinct way, but it was a good question.
Thank you, Evan, for taking that question. So we'll have a quick demo, but more available. So 0.9 has more features than we can fit into today's webinar. I will pass it to Patrick, and then we'll do a demo now.
Thanks, Murat. Yeah, so what I wanted to show you guys today is local PV. We're really excited about this. We got a lot of requests that came in. OpenEBS across the board for all of the storage engines is ridiculously simple to use. I mean, it has been and it always will be ridiculously simple to use. But there were certain people that came in and said, well, I have my replication and things like that are being handled at the application layer, and I just need a fast as possible, just basic storage engine. So we came up with local PV. Let me share my screen now. Let me hold on real quick. Okay. Can you guys see my browser window, Murat?
I can. Yeah, you're looking at.
Good. Thanks. So this is real quick. I just want to show you guys some of the information about local PV, and then I'll jump in and show how incredibly easy it is to use. But yeah, so we had these requests for something as close to just raw writes to the device as possible, and so we came up with local PV. Local PV has two different options for how you can use it. You can use it based on host path, which is just a path on the host, if you would believe that. Or you can use it based on an actual block device that's attached to the host. So You can see if you go to our documentation guide under user guides or our documentation site, under user guides on the left, there is a local PV section, and it'll give you the specific detail on how to deploy via host path. So here's like how you define the PVC for host path. And then it also gives you an example of how to do that for device. So here's one, it's very simple, very easy to understand how to do that. But what I want to do now is, now that I've kind of gone over the concepts of it, is I'll show you how easy it really is to invoke. So I have a basic Kubernetes cluster here. As you can see, I spun it up a few hours ago. If we do So I have installed OpenEBS on here, and you'll see that there is a storage class that gets installed by default called OpenEBS host path. So if we do a git on that and show the YAML output, you'll see that by default it points to a location called var OpenEBS local, and that's where it will create these PVs is on disk there. So it's really simple. You can use this out of the box, or you can create a custom storage class that writes to a different location, whatever works for you. But for this particular example, I'm going to go ahead and show how I'm using this storage class that came with it. So we go into, sorry, that's really small. Let me. So if I'm going to do a Jira deployment here, and you'll see that I have my persistent volume claim. And with the persistent volume claim, I just say the storage class I want to use is OpenEBS host path. And I give it a size, just like I would with any previous storage classes that CStore or anything like that I had defined. And point my volume to the PVC. And then I go ahead and deploy it. kubectl apply. And it's as simple as that. I mean, there's the PVC, and the PV gets deployed, and we're good to go, and we're up and running, and it's as simple as that. I mean, it's really just as easy as anything else. It's super fast, super easy to use, and as I mentioned, I think Murat mentioned earlier, it's really, really close to the same speed as writing to the raw device. So yeah, that was just what I want to show you guys. It's a really basic demo of local PV. I'm going to pass it back over to you, Murat, because I think you had some things you wanted to go over also, right?
Thank you, Patrick. So yeah, we have also, let me share my screen. We have also a couple of things, especially with the Velero plugin. Now there is a OpenEBS Velero plugin. So let me. You can get access to this Velero plugin from the same repository address, OpenEBS/Velero plugin. And first of all, you need to have the Velero bits installed to be able to get this up and running. But after that, installing OpenEBS bits on top of it is really simple. Velero plugin add OpenEBS Velero plugin.ci. This takes it from the latest build. And then you have to have your bucket created, S3 bucket created, and then backups will go to that S3 bucket. But what I would like to show is, let me bring up my environment. A cluster here. You find a cluster, and what you are looking at is a Maya Online. So now we have new application, VU application workload dashboard available on Maya Online. And so what it does, so on the back end, we have a new functionality also introduced here. you can take a scheduled backups to your S3 backend using MyOnline. This is on the backend uses a bit more than the Velero plugin, but pretty much the same idea. You can schedule your backups. So I picked one application here running on one of our Rancher cluster. And once you do that, so you have a couple of options here. Today there is only AWS and Minio option available, and you can add your cloud credentials, and then this can be also done through CLI, but really simple to use through MyOnline. You can set up your schedule, cron time, daily, hourly, and with the hourly you can set every hour, and then it detects the regions, US East 1, and schedule it. So this takes, oops. Yeah, your account needs to be on the trial mode, but this will take a scheduled backup every hour, and then from that view, let me find another cluster here. And then you will get all your scheduled backups on the DMS view. Let's take a look at one of this, and then this is taking a scheduled backup of Minio on my Rancher cluster. You can see a list of backups, and again, the benefit of using Velero with CStore is your backups are differential. So it is only the delta, and you can see actually the benefit here. It's a small data set, but imagine this was hundreds of gigs. The initial backup, and then the delta is here because there is not much difference, kilobytes. Even if you didn't have any difference, that would be again the whole data set without. And from that, you can see the files inside. And from list of your restores, and then this shows the restore scheduled previous restores. You can see your successful restores. This is the DMS demo part of it.
Yeah, and use cases. I mean, how would you summarize how people are using DMS or just the open source Velero plugin and so forth?
Yes, a couple of use cases. The largest one currently used by community is, of course, efficient disaster recovery. So, and you may have seen this on social media a couple of weeks ago. Companies rely on one cloud vendor or one platform are risking their business. So if you are on one cloud vendor and not really have a multi-cloud strategy, that outages can be a disaster. So in that case, with Velero plugin or DMS, you can take a scheduled backup of your application with the persistent data that includes configuration of the application and the data itself. And you can actually bring this application up and running on any platform. It doesn't have to be the same Kubernetes cluster. So you can imagine this can be a disaster recovery solution, also kind of a manual migration solution. You can take a backup of your application and then bring it up on a another cluster and then flip the load balancer from one cluster to other and switch the service. Kind of the early days of data migration, and then kube move will make this simpler.
It's also really good for a lot of our users tend to have a separate Kubernetes cluster per environment. So for their dev cluster and their test cluster and their staging cluster and their production cluster. And this is a really great way to ensure data consistency. So you can take your snapshots of production and push them down to all your lower environments. So you know that your testing is being done on the most accurate data versus what you have in production. So it's really kind of a smooth way to do that.
Yeah, kind of the old days of, yeah, you have this release candidate builds. Yeah, you can take a snapshot of backup and test in your test environment. And if it is proven, then you bring that application with the data up and running in production. So from between the clusters, you can easily move around your application with the data. This wasn't possible before for stateful workloads. Of course, it's much easier with stateless.
Yep. I thought you were just going to say Kafka, but that's okay. But obviously, we get a lot of, there's just a tremendous amount of, there's actually a couple partners in the channel pretty frequently talking about, starting to talk a little bit about OpenEBS behind Kafka, rolling upgrades. I mean, these use cases you just described are horizontal in nature. Obviously, like Kafka is a workload, but it speaks to this federated approach to data stores. Kafka enables some of that as well. And then if you have a lot of different data stores, you probably want something like CAS and OpenEBS underneath them. But if I had to draw a heat map, Kafka would be obviously an area we're getting a lot
of the top, yeah,
a lot of adoption, but GitLab is would be right there.
Another one, yeah.
There's a lot, and thankfully, as you said earlier, increasingly the community itself and partners from the very, very largest global system integrators in the world. Of course, WordPro has been talking a little bit about us as an example, through to your bespoke, per town, per city DevOps Kubernetes experts are now starting to contribute back at least their expertise, which is great to see.
Before we close, the summary is, OpenEBS, our community is bigger and stronger than ever, and now we have a CNCF and their power behind OpenEBS as well. And as you have seen from a quick DMS demo on Maya Online, so Maya Online is the platform for OpenEBS and then monitoring your resources, storage resources and applications, and managing your data migration strategy. Really simplified user interface for managing OpenEBS itself. And we are getting close to this next exciting milestone, 1.0. This week, we are testing the RC1 bits, and at the moment, actually, we are always multitasking, so running some workloads on the backend. And of course, this is a community, and we really welcome and appreciate your feedbacks and PRs that can be in documentation, it can be in the code. And we really appreciate your support behind OpenEBS.
Yeah, I'll jump on top of that and just say again, thank you, everyone. This is we're not about solving a problem for Kubernetes alone. We're about using Kubernetes to do things radically better when it comes to the management of stateful workloads. And that is kind of our North Star, our guiding light, if you will. And we're seeing it. Some of the things, I just retweeted something on the side where a partner of ours showed deploying back to Kafka, a Kafka pipeline with us, with Rancher, in about 100 seconds, and being able to validate it with Litmus that it's all working well. I mean, years ago, that would have been somebody's quarterly objective, right? And now, thanks largely to Kubernetes, it's able to be done in not the blink of an eye, but let's say a minute, 2 minutes. It's amazing. And so it's a really exciting time, but we need the community to help through feedback, which has been happening. But also tell your friends about KubeMove, tell your friends about OpenEBS. If you look at us as a company versus a traditional venture-funded company, we're entirely engineering. I mean, I'm the least, I did a pull request the other day, but in general, my pull requests don't get into the code, right? I mean, everyone else, me and Phil are probably the two guys not touching the code. We are really betting 100% on code as marketing. And for that to work, we need word of mouth. And so please continue to tell your friends. And hopefully you see the trajectory. We've come a long way in a couple of years since open sourcing. Hopefully you can believe in the trajectory because where we're headed, where we are now, but also where we're headed is pretty exciting. And maybe another question, Murat.
Yeah, thank you, Evan. And let me retake the question from Devon, because yeah, I think this is asked very frequently, and also we get the answer from users as well. Can I run OpenEBS on EC2 with EBS? So to be honest, I was asking this to myself a year ago as well. What is the benefit? But continuously we are seeing this from community and our users and enterprises that many of them actually cannot run anything on EC2 on EBS without OpenEBS. And let me explain the use cases they find it useful a bit. So one main use case, this is probably the not the largest one, but very common. If you run your instance on a EC2 with an EBS, and then EC2 instance restarts, may come back up in another availability zone where your EBS is not available, and then you lose the storage. In that case, users use OpenEBS to abstract and also provide across availability zone functionality. You can have replicas across availability zones. That way, your EC2 instance still has an HA storage. And another one is also this is increasing. It's a very interesting use case. So the biggest part, if you look at your cloud bill, the largest part is probably the after compute maybe, but storage. But this is mainly because it is most of the time over provisioned, because you don't want to unmount or your volume and then resize it, or most of the time you cannot. With OpenEBS, you can thin provision, create a large volume, but the backend of EBS can be as minimum as AWS allows 1 gig, and then when the need grows, that you may not project this from the beginning always, and you can add additional EBS volumes into the pool and grow the volume. That way, some of our large users reported that they have over 50% of cost saving, just increasing their storage capacity over time. That's a nice one. And also known EBS issues. I think I don't face this a lot, but it comes back in community, mount, unmount issues.
Yeah, we've got one more question, but also, you know, I was just talking about how you can support us. And, you know, there is another way, which if you forward the slide, Murat, I mean, yeah. we do welcome customers as well. So this isn't intended to be, you know, a hard sell, but for sure, as you roll us into production more, even if that production is a CI/CD pipeline, having that peace of mind may be of interest. And we're running this a little bit of I guess a promo where we're adding some more professional services on top of the ongoing support. So you can find all this on the MayaData website. And I think the next slide maybe says something about this promo now.
Yes.
Okay, you can head back, but you know, it's there. It is. Yeah, it's pretty straightforward to get started. It's not. We think of it as not a lot of money. And the thing I would say is we've gotten some customers recently. We have a good support organization. We will not add more customers than we have the ability to make loud as possible public references, if you can be a reference, or at least we're going to make every user a customer wildly successful, end of story, period. So so if you are interested in this, you know, jump on board pretty soon, just because coming out of Kubecon, we're getting to the point that this summer we're likely kind of slow down some of this and be a little less aggressive in terms of pricing, just so that we can make absolutely sure every user is a reference. But Richard, whom we haven't mentioned, but Richard does not work at MayaData, but he does help with the OpenEBS project.
And he's our maintainer as well.
He's a core maintainer of OpenEBS and a known engineer leader in the storage industry. Also was just asking the question, hey, how does kubemove compare to VMware's storage vMotion? And my quick response was conceptually similar, but vMotion does have, you know, the engine that actually moves the data. Kubemove, first and foremost, while we have our own engine that can help you move the data, Kubemove, first and foremost, is the suggestion that, hey, let's extend Kubernetes itself so we have open APIs so that you can call this in an open way. And what's happened is there are some cloud providers out there now extending Kubernetes to do things like move in a non-open way and with proprietary APIs. And so for us, this was it's a little bit similar to the service mesh set of interfaces that was open sourced and added to CNCF recently. Let's do that at the data mobility layer. So it's a bit thinner than to be open than vMotion, and it's more of the openness of the APIs themselves. But we can't just publish, here's some APIs. So if you look at kubemove, we also have some example CRDs, custom resources, that you can grab so you can kind of get your arms around what we're looking at and what others in the community are looking at. That's a great question. I'm going to add anything to that.
Thank you again, Richard and Evan. Thank you for attending this. I think if we don't have any additional question, this concludes our webinar today.
Great.
Thank you, everyone.